Hello, my name is Urvi Kaul and I'm starting graduate school this fall at the University of Connecticut.
Hello, my name is Brittany Clark and I am currently a student at Georgia Southern University in Savannah.
From May 19th to July 12th, 2021, we participated in the National Science Foundation Research Experiences for Undergraduates program hosted by the University of South Alabama with directors Dr. Leslie Gregorica and Dr. Jamie Ollinger. We conducted research on human skeletal remains recovered from two tombs called Unar I and Unar II, which date to the Umanar period in southeastern Arabia. The Umanar period occurred during the second part of the early Bronze Age from approximately 2700 to 2000 BCE. The tombs are located in the Emirate of Ras Al Khaimah in the United Arab Emirates, or UAE.
The Umanar period brought with it a shift to a more sedentary way of life, or the practice of living in one place for a long time. This major change was due to the development of oasis agriculture. During this period, there was heavy reliance on cereal crops and date palms. Marine resources, herding animals like goats and cattle, and hunting were also used to supplement agriculture.
The Umanar culture extended throughout the UAE and northern Oman.
Umanar tombs contain hundreds of human skeletons that over time became commingled, meaning that individual bodies were not interred separately in regard to social status, but were instead placed together as a group. Following decomposition, their skeletons were pushed aside and became mixed together over time as later individuals were interred. This has been theorized as a way to promote social equality throughout the community.
Brittany and I focused on the survivorship of individuals interred in both tombs. We first assessed whether stillborn individuals were allowed to be interred in the tombs alongside older infants and adults, and then looked for signs of cribra orbitalia. Cribra orbitalia refers to skeletal lesions in the eye orbit that can indicate nutritional deficiencies or some other stress these individuals experienced as children. We hypothesized that tomb Unar I would have a higher proportion of individuals with active cribra orbitalia and a higher proportion of stillborn infants interred. This is due to an increased reliance on agriculture and sedentary lifestyles towards the end of the Umanar period, leading to a decrease in overall health and nutrition.
To assess the presence of stillborn infants in both tombs, we looked at micro-CT scans of infant bones. Micro-CT refers to a kind of three-dimension image that can reveal the microscopic structures of bone. This technology enabled us to evaluate bacterial bioerosion, which is the process of bacteria breaking down the structures within bone during the decomposition process. Infant bones that do not have evidence of bacterial bioerosion in their bone scans are considered stillborn because they did not survive long enough outside of the womb to breastfeed, a process which provides them with bacteria within their guts causing bioerosion after death.
Using these micro-CT images, we can determine the presence and extent of bioerosion without having to damage the bone to create microscopic slides like in previous methods.
We assess levels of bioerosion using a method known as the Oxford Histological Index. This method provides a score for bioerosion ranging from 0 to 5, with a score of 0 being the most heavily bioeroded and a score of 5 associated with a lack of bioerosion. Individuals identified as having a score of 5 were classified as stillborn.
Out of the 22 humeri, or upper arm bones, that were scanned, we found numerous infants that appeared to be stillborn from both Unar I and Unar II. This indicates that stillborn infants were permitted access to Umanar tombs and were not segregated in some other burial space. There was no statistically significant difference in the degree of bioerosion observed between the tombs, and there were also no differences in the proportion of stillborn infants to live births.
The second aspect of our project involved looking at cribra orbitalia in individuals from both tombs. We expected to find a greater proportion of individuals with active cribra orbitalia in tomb Unar I compared to Unar II.
We created a method for assessing the amount of eye orbit present due to the high levels of fragmentation in these skeletal collections. The method involved creating zones on a model with complete orbits and then scoring these zones as present or absent. Using the zones, we were able to calculate the percentage of the orbit present and annotate exactly which area of the orbit where lesions occurred.
Once we scored what percentage of the orbit was present, we then assessed if cribra orbitalia was present or absent. When lesions were present, we scored them for both the severity of the lesion as well as the degree of healing present, if any. By looking at severity and healing, we can begin to understand patterns of health and morbidity within this sample population.
We scored severity on a scale of 0 to 4 and scored healing on a scale of 1 to 4. A severity score of 0 meant there was no cribra orbitalia present, while a score of 4 meant cribra orbitalia was severe. A healing score of 1 indicated no healing had occurred, while a score of 4 indicated the lesion was almost completely healed.
We found similar rates of presence and absence between tombs Unar 1 and 2. Additionally, while there were no statistically significant differences in the measure of severity between the tombs, we did find a significant difference in the degree of healing when comparing left orbits from both tombs.
Overall, we concluded that our hypotheses were not supported. Based on our evaluation of both cribra orbitalia and bacterial bioerosion, we can infer that there were no significant changes in health or fertility rates between the periods that these tombs were in use.
This suggests that despite the intensification of agriculture and an increasingly arid climate in the region, the local inhabitants of this area were able to successfully adapt to their changing surroundings in a way that did not negatively affect their health.
We would like to thank the National Science Foundation for funding our research and the Ras Al Khaimah Department of Antiquities and Museums for permission to study the remains for our project. We would also like to thank Drs. Dwayne Bucco and Sharon DeWitt for their consultations, as well as Drs. Leslie Gregorica and Jamie Olinger for their wonderful leadership throughout our project.